As long as algebra and geometry has been separated, their progress have been slow and their uses limited. But when these two sciences have been united, they have lent each mutual forces and have marched together towards perfection.
Den interplanetære podcasten. Utforskning av rom til fordel for hele menneskeheten. Dine verter i England og Norge, Matthew Russell og Chris Carney.
Oh yeah, baby.
Oh yeah, baby.
Lagrange.
Definitely a favourite, isn't he?
Oh yeah.
Old Joseph Louis Lagrange.
What a guy.
He was born on this day in 1736. A long time ago, isn't it, that?
Yes, very long time ago.
1736.
Yeah.
He's an Italian-French mathematician and astronomer.
Did you hear any of the Italian I put into that then?
I did spot a French-Italian mix, which was very clever, and that you'd put it in the kind of French dialect you'd expect from the 18th century.
Oh,
very clever
yeah,
indeed.
Absolutely. It's done my research, and to give it that Italian edge to it, I did it while sitting in my Maserati.
Now, I was trying to get my head round it, because that seems a long time ago, considering what he achieved, and I was trying to get my head round about who was around at the time, and the one that I was really surprised was that Lagrange was born 23 years before Robbie Burns.
Happy Burns Day, everyone, or Burns Night.
He's born on the same day as well.
Yeah.
Robbie Burns is 23 years after Lagrange.
Yeah.
And Lagrange is almost exactly 100 years after Newton. Not exactly, but, pretty much just under 100 years after Newton.
Give or take.
And he's living, of course, in revolutionary France, where everyone's having their heads cut off all over the place.
He's also 245 years before Alicia Keys.
Yeah, absolutely. Who, if you listen to my other podcast, you'll have discovered doesn't use auto-tune.
Oh, doesn't she? Oh, she's got a wonderful voice.
Mentioned Alicia Keys on 2 podcasts in the same week, which is pretty cool.
Amazing.
The pedigree of Lagrange. He was a student of Euler, one of the greatest mathematicians of all time.
Of course.
And a student of Jean-Baptiste Laurent d'Alembert, who is also an amazing mathematician. But Lagrange was a teacher to my favourite mathematician of all time, Fourier.
Fourier. He's one of my favourites too.
Oh, well, without Fourier analysis, we wouldn't be able to do this podcast because there'd be no way of getting our digital audio onto the internet.
Correct.
But what did Lagrange do? What didn't he do?
He didn't sleep much.
He didn't, actually. No, he didn't. He used to keep himself awake with tea and coffee.
Good choice.
Kept himself awake to work throughout the night. And his vision at the age of 20, if only students these days at the age of 20 had a vision like this. And this is what he says: I will deduce the complete mechanics of solid and fluid bodies using the principle of least action. And he did a single uniting principle. Turned out to be virtual work rather than least action.
Oh, everybody knows that these days, don't they?
Yeah, that's what our lives have become, isn't it? Virtual work. But he was doing that in 1763, discussing the libration of the moon. It's one of the most important theoretical mechanics since Newton.
Lagrangian mechanics.
Lagrangian mechanics. He got involved in the metric system as well. He got involved in longitude.
It won't catch on.
In other words, trying to navigate without making your ship run aground in Cornwall, where you get beaten up by pirates.
Oof.
He developed calculus into some of the things that mathematicians use today. So the name Lagrange is absolutely everywhere. But, of course, a firm favourite of the podcast is the fact that he studied the 3-body problem and discovered these Lagrangian points, which is the libration points where the gravitational effects of 2 masses equal the centripetal force necessary for a smaller mass to move with them.
Wow.
really famous example of that, which ties in with a mission that's going this year, the Lucy mission, is that Jupiter has trojans, and these trojans travel in front of Jupiter on its orbit and behind Jupiter on its orbit. There's just loads and loads of sort of asteroid-type bodies that are stuck in these Lagrange points. And, of course, Lagrange points is where they stick things like, hopefully, the James Webb Telescope. It's almost like you can see it as a kind of little hill in between two gravity wells where it's just on the edge, where it will sort of just about stay in position. Oh. And they're beautiful. The mathematics of Lagrange points are just incredible. And Lagrange sorted it all out. And there's, for satellites and spacecraft and understanding the solar system, it's one of the big things.
So one thing that always makes me think about this type of like a Lagrange point is like it's pre-industrial revolution. So do you think someone like Lagrange could envision that one day somebody would be essentially placing something on one of his points?
Do you know what? I don't know. I really doubt it, because that whole it may have just been perceived as being absolutely impossible to sort of get out into space. I mean, there's not even close to getting there. Really interesting, wouldn't it, to read the I guess science fiction of the time, if there is any. Oh, you've opened up a really good, cool thing to think about there. The science fiction.
I think the science fiction
late
at the time,
18th century.
I mean, the fiction that wasn't fiction, it wasn't regarded as fiction, but it was basically the Bible, wasn't it? I mean, they were your stories. That's all you get.
Well, no, it's after Shakespeare, isn't it?
Oh, of course, yeah. I didn't think about it. I was actually thinking about Chaucer just as you said that. I was like, Chris, come on. People had imaginations beyond the fucking Bible. Excuse my F words there. I watched that Elizabeth, the Golden Age the other night, which is it's Cate Blanchett playing definitely a far more attractive Elizabeth I than I imagined she actually was. But yeah, that was that was quite interesting, because it was the defeating of the Spanish Armada, which led to this sort of this era of peace and prosperity, and really a sort of a small cultural renaissance in the UK, which Shakespeare was a part of. But it kind of wouldn't have happened if the Armada would have been successful. We would have just had, 500 years of the Inquisition.
Well, what's not taught is that about a year later, the English got completely destroyed trying to rout the Spanish on the way back. So they thought, right, let's go and finish them off, and they got absolutely mullered. But we don't teach that in school for some reason.
It's weird, that, isn't it? It's so strange. It's so weird that we don't teach that.
So it'd be interesting to like Spanish people like listening to the podcast going, what's this Spanish Armada thing? Never heard of it. Yeah, so Lagrange, it's his birthday today. Hip, hip, hooray. What a blooming legend.
Have a good one, mate.
Now, also on this day in 1994 was a spacecraft called Clementine.
Oh, my darling, oh, my darling, oh, my darling Clementine.
And that song is perfect, because it was named after that song.
No.
Because after its mission, it would be lost and gone forever. Just like the Clementine in the song. How cool is that?
That's so cool. Oh, that is me just having a little sing-song to myself.
This is one of these spacecraft that's testing out the very latest sensors and equipment on satellites, and sort of doing work sensing the moon and things like that, and mapping the moon using these various sensors. So it was a pretty important satellite. It didn't quite go to plan. It didn't finish off its job of looking at an asteroid, but it did a pretty good job.
Not a finisher. Not a finisher.
Not a finisher, but still. But it is lost and gone forever.
Oh,
my little darling Clementine. But you're in Norway, aren't you, today?
I certainly am. I'm now living in Oslo.
So I'm going to have a Norway section here.
Yay.
And here is, I need to read out Sigmund Eid, who is our ace level patron. He joins the two Justins And I've got to give him a shout out. Sigmund, you are an absolute legend, and your help, your patronage, has helped buy, for example, Harriet a little microphone so she could do last week's show and some more co-hosting into the future. So stuff like that, that's what keeps the podcast going. So Sigmund, you are indeed an absolute legend. And one day, hopefully, when all this nightmare is over, Chris and I will visit you in Norway, and we can have a drink together. What's the Norwegian drink of choice?
We may well share an akavit together, which is it's a bit of an acquired taste, but once you get into it, there's no going back, to be honest. So yeah, maybe some of that. Either that or a bunch of moonshine, because that's basically one of the big things here.
We could all go and watch the Northern Lights together.
I would love that. I've never seen them.
Oh my God, that would be absolutely insane. Right, that's it. We're doing that. That's what we're doing. Sigmund, you're coming to see the Northern Lights with Chris and I.
Big up, Sigmund.
Get this. Another Norway thing. 1995. The Norwegian rocket incident.
Den norsk rockethendelsen.
Oh, nice.
No worries.
Yeah, it was the Black Brant 7, which is as you know, is a Norwegian research rocket.
Of course.
That launched as a test rocket, doing science, doing valuable science. And it launched on the 25th of January, 1995. And out of Andøya rocket range, which is off the northwestern coast of Norway. Have you ever been up that high?
I've been very close to it. I was just looking at it before. It's on the same sort of archipelago as Lofoten, which is a beautiful part of Norway, and it's very close to where Kaja grew up. And when we say very close in Norwegian terms, it's actually like 2-3 hours drive. But she grew up in Narvik, and Narvik is fairly close to. You sort of access those islands around the area of where Kaja's dad was from, which was Lodingen. But yeah, I've not been there, but I do know Andøya means Duck Island. Quite well known for its fish. It's known for space, and it's known for cycling, but it's called Duck Island. So there you go. I'd like to go there and do some cycling someday.
Well, we should definitely take it in if we go to Norway.
Definitely.
On a trip. But here's the bad side of this. There is a early warning radar station in Olenegorsk.
Yeah,
in Russia, and that picked this thing up. Now, the crazy thing about this is, when that rocket went into that bit of airspace, that is the bit of airspace that goes from North Dakota to Moscow. If you fired the Minuteman III nuclear missile from North Dakota, so. This would, obviously, the Russians have got their radar trained on that particular corridor, and they saw this missile blipping up on the radar, and of course, at this point, it's like, whoa, what's this, right?
Yeah.
They don't have any idea what it is, and what the Russians are terrified of is that this is the exact sort of thing that America would do to wipe out their radar. So this type of nuclear device would explode very high up above Russia, send out loads of gamma rays, creating this electromagnetic pulse, an EMP type attack, and blind and confuse all the Russian radar before an actual nuclear attack, so that they couldn't, even attempt to try and shoot down or whatever they were going to do against American attack. So they now have 10 minutes to decide whether to end the world, essentially. This is like a retaliatory all-out nuclear strike
MAD.
That would happen.
Yeah.
Yeah, MAD, mutually assured destruction. So 10 minutes they've got to decide. So they track the trajectory for 8 minutes. So for those 8 minutes, they still don't know what this thing is. And they take 8 minutes only to find out that it's been launched from Norway and is going in really the opposite direction. It's not going in that right direction. But in those 8 minutes, the Cheget, and now the Cheget is the nuclear briefcase that Boris Yeltsin had. This is the nuclear briefcase.
Yeah.
Where all the codes and the key and the big red button are in this briefcase. And it was activated, and Yeltsin had the nuclear keys out. It's the only time, the first and only time that any state has got its nuclear briefcase activated and prepared.
This is incredible. It is absolutely amazing. Proper squeaky bum time for Boris Yeltsin there.
So Yeltsin's sitting there. And Boris, I think back in 95, that was his boozy days as well, wasn't it? Old Boris. That's when he was doing his crazy dancing on podiums while absolutely mullered, if I can remember right. So it's like, wow. So literally 2 minutes to spare before, the Russians retaliate.
Yeah.
And apparently the Norwegians had sent out notices to 30 countries, including Russia, to say, look, we're doing these scientific tests just like they always do. But for some reason, it hadn't been passed up the chain to the radar operators. And so, it was very nearly the end of the world.
Do you think that's why they invented read reports on text messages?
Well, the crazy thing is, you think how often this happened. It happened with SpaceX, where ESA, phoned up SpaceX and said, you do know that one of your Starlinks is just about to knock out Aeolus, which is one of our newest, most technically advanced weather satellites, one of a kind, and the Starlink might hit it. They didn't get a reply, so the European Space Agency had to move the satellite themselves.
Yeah.
And then SpaceX, we didn't get the email. It's like, what? This is just madness. This is just like insane. So it's
the email should have been a meeting.
Yeah, it's a bit like, maybe get on the phone and say, what are you going to do about this? Because this is a little bit stressful.
Yeah.
That's one of many times the world nearly ended because of nuclear.
It's just
accidents.
An absolute miracle that we're all still here, isn't it? To be honest,
it is actually when you read about the close calls with nuclear accidents. I'm laughing, but can you imagine if something like that?
Well, we wouldn't be imagining now, really.
Oh God. There's one more birthday. There's one more birthday to do. And it's the birthday of IRAS.
Yes,
IRAS, which was the first ever infrared orbital observatory, which was launched on a Delta 3910 from Vandenberg on the 25th of January 1983.
I was four.
It's the first ever space telescope to perform a survey of the entire night sky in infrared. And it did it at about 5 different wavelengths. It was a 10-month mission. It was a joint project by the Americans, the Dutch, and the British. And it's the precursor to things like the Spitzer Space Telescope and the Infrared Space Observatory and Hubble, and Hubble's NICMOS instrument. So it's a very, very important instrument, but it discovered a lot of things. This is something that was, it's the first time we looked at the universe in this particular light.
Yeah.
And it discovered things like planetary disks around stars. It discovered 6 comets out of the 22 from that year. It also found, and this was announced on the 10th of December 1983, that they had found unknown objects, possibly as large as the planet Jupiter and possibly so close to Earth that it would be part of the solar system. So you're thinking in your head, Planet 9, it's Planet 9.
Must be Planet 9.
This must be Planet 9. But it wasn't. Although you'd have called it Planet 10 back then, because Pluto was still a planet.
Of course, yeah. Poor Pluto.
Yeah. However, it was a thing called intergalactic cirrus.
Space word of the week!
I think it is Space word of the week, which is intergalactic cirrus. And this is interesting. I'd not heard this phrase before, and it turned out it's quite hard to look up what it actually is. I was trying to find some papers, and it seems that This is something that Sophia looks at quite a lot. The telescope that's sort of drilled into the side of a Boeing 747. That's space that they're able to sort of fly up into the upper atmosphere.
Glued on like an ear on the back of a mouse.
Exactly. And Sophia looks at this stuff. It's good for looking at this stuff. But it's the infrared cirrus, as its name suggests, are clouds. Galactic clouds, and it's the sort of galactic filamentary structures that are seen everywhere in space. So the way I kind of think of it is just very, very loose dust that's kind of got some structure to it, all around the galaxy. And it's absolutely everywhere. But of course, it clumps in different ways. So you kind of have these wispy clouds of it and things like that. But this dust is just about warm enough that it's got this infrared signature. And it's really useful as well, because you can infer certain things about the way that the galaxy was forming and what the gravitational structure must be like and things like that. So I guess it points to things like dark matter and helps with things like that. But it's a very interesting phenomena that I'd never really seen that phrase before, intergalactic cirrus.
But the thing that fascinates me is that it's the size of Jupiter and it's very close to Earth, did you say? So it was within our...
It wasn't that. So it wasn't... But imagine you get a two-dimensional picture back and you get this... You get what looks like a ball of light, or even just like the edge of it, maybe you just sort of see a crescent and you infer that, oh my God, what is that? Well, maybe it's a planet. But then what it actually is something much, 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 much further away that's hundreds of light years long rather than the size of a planet.
I get you.
And it's the dust that's sort of basically so diffuse and just about warm enough that it's being picked up in these infrared wavelengths. It's away from things like stellar formation, so you don't get all these shock waves coming off supernovas and stuff like that. It gives you a little bit of more insight into the structure of the universe and the structure of galaxies and how they all interconnect and stuff. So
I like it. I like the it rolls off the tongue. Intergalactic cirrus. It's really nice. You wouldn't think it's just talking about a little bit of old dust.
So, Chris, you had a really nice story.
I've got a lovely story here. So first off, little bit of news that is on space.com came out today. And it is that the Apollo landers Neil Armstrong's boot print and other human artifacts on the moon are now officially protected by a new US law, which is really sort of something that you might not really think about, but it is part of human heritage up there. And because, no one's been there for a very long time, but I think obviously people have just realized that we need to step this up because there's so many more missions that are going out there that they've compared it to things like Machu Picchu, where it should be recognized globally, even though it's a law that's come about in that particular country. So it's kind of like a off-Earth heritage, off-world heritage, could you call it? So, it's I think it's really important. But I mean, one of the obviously problems with it is that it's pretty much unenforceable. I mean, you could be on a mission from any country and go up there and see Neil Armstrong's boot prints and just be like, just give that a little wipe off and just scrub it away, and nobody would really know it was you, and there's no way they could actually prove it either. So it's unless they do send Space Force up there to just stand there next to his boot print and the flag and just be like, no, step back, please. I don't know how they're going to enforce that one. So I just think it was quite an interesting thing that there's actually legislation at work here to make sure we're preserving very important parts of our history off the Earth now as well as on the Earth. But the second one was quite a nice thing, really. I think it was sort of, I want to say, heartwarming. And this is from actually reading this on the gov.uk site, and it's a satellite-powered app to spot loneliness in hotspots in UK cities. So it's government-backed, and it's going to aim to tackle loneliness, and it's been adopted first by Leeds City Council. So it's going to enable CareView application. So it's called, the satellite-enabled curfew application, it's going to tackle social isolation and loneliness in urban areas. So about the help of an army of professional volunteers who are attached to it, including police workers, postal workers as well, and charity workers. They'll register on the app, and if they see signs that somebody might be experiencing social isolation, that could be anything from, maybe rubbish building up outside, or, maybe not answering the door, that type of thing, or just if a neighbour's concerned, they can throw up a sort of a bit of a beacon, and using satellite technology really just to geotag that and enable possibly somebody to rally around that particular person. So I just think it's quite a nice sort of heartwarming space story, really. It's got the connection to satellite technology, so I thought I'd include that one.
It's quite tenuous, isn't it, to the satellite technology? I wonder what precisely that is, because you'd have thought you could just do that just off cell phone towers or something like that. I wonder what how it actually ties in. But presumably that was one of those statements off the UK Space Agency, because they've got quite a few of those projects going where it's like trying to think of novel ways to use space.
Yeah.
And they do seem to concentrate on those community issues, which I think is, and medicine and NHS and stuff like that. Like the NHS has got quite a few of those sort of satellite-based space applications.
But I think they could also use it like to start identifying moon hoaxes. You know what I mean? If you think that you live next door to one, we can just pinpoint that person, just flag them up.
And fire one of those kinetic weapons from space.
Where you're sitting there in the pub, and a mate starts firing up about, the flag was moving and stuff like that. You could just click a little button and just be like, oh, yeah, in the Fox and the Hounds in Worcestershire, there's someone talking bollocks.
In the White Swan in Flyford Flavel, it's coming in. Got a kinetic device going over that in 2 hours. Yeah, so or it just sends in Buzz Aldrin, to say, punch them. What are you doing? Give you a punch. Well, it was his birthday the other day, wasn't he? 91 or all the best fella. Ah, what a diamond geezer! I saw a brilliant one. I can't let this go. I saw a brilliant map of the 50 gravitational wave events that have been verified so far. Oh my God, that is snowballed. That's incredible. Yeah. I know, absolutely, and it's an interactive map, so it's this beautiful, or like an infographic, and it lines them up in their size. So these circles have whatever the mass of the two objects coming together, their combined mass. So it determines the size of the circle. But there's also often little play buttons, so you can listen to the sound, this kind of representation of the sound from the interference pattern from LIGO and Virgo. And it's really, really cool. But it also puts them in order of how far away they happened, and therefore what epoch they actually happened in. So it's kind of like a timeline and a distance line at the same time. It's very, very cool. And you just sort of see all these. It does make you. It just gives you a sort of much. I love those type of infographics because it gives you a slightly deeper understanding. And like you said, I was quite surprised that there'd been 50 of these events now that have been verified. Yeah. So this is by visualcinnamon.com. I've just gone onto the website. Nadia and it's Bremer. Yeah, I'm going to get lost on this website. Definitely. It's amazing. Yeah, it's really good. Yeah, that is really good. And another beautiful thing that I saw, and this was over on Bad Astronomy, the Phil Plait, his kind of blog, which is always worth looking at. And he was talking about a planetary nebula called STDR 56, which is in the constellation of Triangulum. And if you're one of the Justins out in down in Australia, you should be able to get a pretty good photo of this if you've got some good equipment. I think the photo that is on this particular website is a 10-inch scope and something like a 60 hours of exposure time to get this image. But it's absolutely beautiful. It looks like a planetary nebula. It looks very wispy, and they're calling it there's these two basically. This STDR are two amateur astronomers, Marcel Dreschler and Xavier Strotner, who are putting together a catalogue of these planetary nebulas, and hence the STDR, which they're kind of initials. And so this is number 56. And the funny thing about it is they're not even sure that it is a planetary nebula. So
what could it be?
It could be like a supernova remnant. So if you think of, first of all, planetary nebula is a bit of a weird misnomer, as in, and you can blame Herschel for this, because when he first started spotting them, they sort of have, because they're circular in shape, they look like planets that are fading away. So as you look through your telescope, it's like a planet, but it's fading away. So that's what they kind of thought they were, because they didn't realize just how far away these things were. Again, it's this scale thing. It's very, very hard to tell how far away something is when you're looking at it. Almost, there's no sort of frame of reference to tell how far away it is. But nowadays, we kind of understand what these things are. So planetary nebulas, if you have something like a star, something like our sun, anything up to 8 times the size of our sun will do this thing where the fuel starts running out, the hydrogen to helium fusion starts running out, and then it puffs up into a big red giant. And so this puffing up, these outer shells of gas then start to get carried away by the stellar wind of the white dwarf, this ultra hot, dense white dwarf, the stellar remnant that's left behind. And this stellar wind starts puffing up these outer gases. But because this stellar remnant, or planetary nebular nucleus, PNN, is giving off so much UV energy that excites the gas itself, and all the different gases start glowing. They actually start glowing a certain temperature, and that causes all these beautiful nebulas like the Cat-Eye Nebula, the Helix Nebula, Ring Nebula. One of my favourites is the Lemon Slice Nebula. That looks like a slice of lemon.
Sounds very tasty.
And obviously Hubble has just really expanded the view on these, just possibly the most beautiful objects that you can kind of picture in the night sky. But if the star is bigger, you get left with a neutron star and supernovas. And supernova remnants are things like the Crab Nebula. And the Crab Nebulas are quite a bit bigger than these planetary nebulas. Yeah. But they're kind of similar looking. They're still just as beautiful, these supernova remnants. But what's quite hard to tell is that there's 2 white dwarfs in the center of this Goblet of Fire nebula. And one is 3,800 light years away. So that would mean the nebula was 33 light years across. And that is just really too big for a planetary nebula. The gas would have got so thin by that point, it's highly unlikely you'd be able to see it from Earth. But the other white dwarf that looks like it's in the center of all this is 1,130 light years away, which would make the sort of outer bubble only 10 light years across, which is slightly more reasonable. Even then, that's pretty massive. But you still can't quite tell whether it is indeed a planetary nebula or a supernova remnant. But here's the really cool thing. So, I was sort of saying that you take this photo, as one of our previous guests explained. If you can take it in the exact frequency of light that the nebula gets excited by, the gas gets excited by this white dwarf in the center, and so you can really pick out the reds and the blues of the hydrogen and the oxygen glowing with all this radiation.
Yeah.
if you can do that accurately enough, of course, you can work out how fast this bubble is expanding, because if it's expanding, it's moving very fast. If it's moving very fast, it should have some form of redshift on it. And so that you can measure it so precisely that you can tell how fast this bubble is going. And if it's going hundreds of thousands of kilometers a second, then you know it's probably a supernova remnant. But if it's only going tens of kilometers a second, then it's probably a planetary nebula.
Ooh. So do we know? Do we know which it is?
No, so they don't know what it is, because it would require, even though we've got some good amateur astrophotographers taking pictures of it, they haven't used one of these enormous observatories with much more exposure time. That's the only way you can get enough data and enough accuracy to do this spectral analysis.
Well, where are they? Are they too busy or something?
Well, I guess that they're just too busy or too lazy. I think
we need to start rallying round and get them to get their acts together, probably sitting there with their fingers up their hoo-has. And, we need to make sure, let's put some pressure on these guys to put one of the big ones on it. We need to find out.
Well, Phil Plait does actually sort of really plead that people need to find this out, because he's super curious himself, and I'm with him.
Yeah,
it's well worth. I will put the link to Bad Astronomy and that picture, because it's absolutely beautiful. It's really, really cool. And I hope Justin, who's one of our other ace level patrons, who's great astrophotographer, I wonder if he's going to give it a go, see if he can capture that beauty.
Do it.
It's one of these nebulas that's about the size of the full moon in its angular size. So as you're looking up in the night sky, if you could see it, if it wasn't so ridiculously faint, it would be the size of the full moon. But there's no way you can see it with the naked eye. You'll be lucky if you have a clear enough sky to pick it up on very good astrophotography equipment.
Yeah.
But still, it's worth having a go, and that's my challenge to Justin.
Absolutely. Come on, let's see this, Justin.
I've got a great interview. I've got a really good interview that was the second half of an interview I did way back in April. So this was at the start of the first lockdown. Annoyingly, I was supposed to go round Kelvin's house. So it's Kelvin Long, who is an interstellar propulsion expert.
Oof.
But the second half of the interview was about a paper he'd written called about conscious stars, and it's a thought experiment about if a star was conscious, could it use its stellar wind to avoid crashing into other stars?
I reckon it could. I haven't had the interview, but I reckon it could.
So it's a.
I reckon
really
a star can do anything it wants if it puts its mind to it.
Yeah, I loved it, because he gave me a call while coming up with this idea, and for me to just double check some of his maths for him. I don't know why he phoned me, because but I did, and I was really chuffed with myself that I managed to work out what he'd asked me to. And
can you do my taxes this week for me? I haven't done them yet.
For the first time ever, I've given my taxes to an accountant, so I was so scared about them. Because I actually didn't want to pay tax on the podcast earnings. Yeah. I thought it'd be just so depressing if, like, all the Spodcat money went to the taxman. So I actually paid the taxman to make sure it didn't.
Back to the interview. Sorry, I threw you off a bit there, Matt.
I actually phoned him up because I was going to put this out this week, and he said that it's just the paper that he's written is just about to go on archive this week. Yeah. By utter coincidence, I found out, and he goes, "Yeah, it's going to be on archive this week." Although it looks like it's on hold because it's such a controversial paper in terms of its kind of ludicrous premise.
I love a bit of controversy, though.
Yeah, so hopefully, well, look, if it is on the archive, obviously I'll put that link in the notes as well.
Yeah,
I hope. I think it eventually will get on the archive, but hopefully it'll be on Tuesday or Wednesday this week. So that'd be it's definitely fun. But we sort of veer off into science philosophy, the philosophy of science for the rest of the chat, and I enjoyed it. I
look forward to that.
So here is the second half of Kelvin's chat. A Kute.
The Interplanetary Podcast, putting the ace back into space.
I'm going to ask you about your current thing about conscious stars, what that's about.
Yeah, so I began. First of all, I started thinking about SETI, Search for Extraterrestrial Intelligence. And, I visited the Chelsea Hotel in New York, and I was trying to get into the exact room where Arthur C. Clarke and Stanley Kubrick had their big debate about what the aliens in 2001: Space Odyssey should look like, because that's where Arthur was writing the book and the movie transcript at the same time. And Arthur, I was arguing they wouldn't look anything like humans, and Stanley Kubrick wanted them to be humanoid, and they couldn't decide. And it turned out Carl Sagan was in town, so they called him up. So he went to the room as well. So you can imagine that hotel room. Stanley Kubrick.
As cool as it gets.
Carl Sagan. And it was Carl Sagan that suggested, my understanding is he suggested, don't show the aliens. Leave it up to the imagination of the viewer, which is why you don't see them in 2001. But that's an interesting debate. What would life look like? And then in other star systems. And then it's a question of what is life, right? So Erwin Schrödinger, the physicist, wrote a book, What is Life? It was published. He also one of the people that predicted the DNA molecule, essentially. I think he called it the organelle. But he argued that we should take a different perspective, more physics definition of life, such as life is resisting the decay to thermodynamic equilibrium. Okay, so this got me thinking about life first of all. What would life look like in other systems? Would it be humanoid, or would it be radically different, like huge globulous jelly-type fish in a gas giant, for example? And then what's intelligence, right? So this is So I became interested in the orchestrated objective reality theory of Stuart Hameroff and Roger Penrose, which I think is a very elegant theory. The idea that consciousness is not defined at the neuron level, but actually at the microtubule level. So instead of having something like, artificial intelligence advocates believe that consciousness is defined by something like 10 to the power of 16 processing operations per second per brain. But if you take the Hameroff model, which includes the extra 10 billion or so processing operations in the microtubules, then you're up at something like 10 to 26, 10 to 27 processing operations per second per brain. And so that got me thinking about consciousness. Now, it turned out that a friend of mine, Greg Matloff from New York City College of Technology, had come up with an interesting idea a few years back. He was looking at dark matter, and he was not convinced by the current explanations for dark matter and galaxies. You probably recall that the basic problem is that if you look at the motion of stars in the galaxy, they should have by the Kepler's laws. So if you imagine a plot of velocity against distance, you should see the velocity sort of going up and up, but it flattens off unexpectedly, implying possibly that there's more mass in the galaxy than we see, hence dark matter. Maybe it's matter we can't see, it's non-luminous. And there's all kinds of explanations being proposed for dark matter. But Greg was looking at, in particular, stars in the outer parts of spiral galaxies. He was making the observation that, if I remember rightly, that red giant stars move at very different velocities to blue stars. And this is something called Parenago's discontinuity, and no one quite understands what it is. But Greg, I was running a symposium quite a few years ago now, the BIS, on Olive Stapledon. It was a British philosopher from Liverpool who wrote a couple of wonderful books, Last and First Men and Star Maker in the 1930s, who also influenced Arthur C. Clarke. And Stapledon had the idea in one of these books, I think it was Star Maker, that stars were actually conscious entities that were moving under their own volition. And I don't want to spoil it too much, but there's a horrendous scene in one of the chapters where the stars start committing suicide. The stars start going out. I haven't read it for some years, but it's an amazing book. And so this ultimately, when Freeman Dyson came up with this concept of Dyson spheres, which really should be called Stapledon Dyson spheres, the idea of trapping an enormous radiation cavity around a star to, like a high Kardashev civilization would do, to trap all of its radiation. He was actually getting the idea from Stapledon. It's just that he wrote this paper in the 1960s Actually, I only read it the other day. It's literally one-page letter published in the journal where he does these amazing calculations. But then I had a thought that I should go back. Greg, we organised a symposium in London, and Greg couldn't make the symposium, so I presented his paper for him, which is on Olive Stapleton's idea of volitional conscious stars, which is a very controversial idea. And at the time, I was editor of JBIS as well, and we managed to agree to publish a letter on it in the journal, and that got him started. And since then, he's been writing lots of papers, a book, and giving lots of talks on the idea that stars may be conscious entities. Now, this is really interesting because, of course, lots of the historical religions in the past have worshipped the sun like it's a god. So I started these conversations with Greg and a few others, including Rupert Sheldrake and Julian Goff, Philip Goff, and Clement Vidal. And we've been discussing conscious stars, and this for the last few months. And we were meant to have a meeting in June, but we rescheduled it. It's a private meeting, but we're having these really interesting discussions on the idea of whether a star could be conscious. So, I've not made up my mind, because I studied astrophysics on my master's degree, and I did stellar structure and evolution, and I understand how stars are created and how the gas cloud fragments and collapses and produces fusion ignition when it gets to a certain percentage. I think it's 8% of the mass of the sun. And then you get stardom and fusion ignition of the core, burns the hydrogen for billions of years, and it moves through the main sequence eventually. Eventually blows up to a red giant. Or for other stars, they become supernova. And some stars become black holes. They're massive enough, more than about 3 times the mass of the sun. So I have studied astrophysics and stellar structure, and I think we have a good handle on the equations of the star. So I was a bit skeptical. But I started doing some calculations just out of interest, as a thought experiment, on the idea of volitional motion. So Julian had suggested to me that could a star actually use its stellar wind or coronal mass ejections to push itself? And so I've actually been doing this calculation for the last week. And originally, when I did the calculations, I concluded it's just too weak. I mean, it's like 1 million times weaker than an ion thruster in terms of the actual. If you assume it's like a big rocket, it can push itself. But I since rerun those calculations, and with coronal mass ejections in particular, and it's amazing that you can actually get up to decent velocities and actually push the star. And I found that actually, it's possible to move the star over tens of AU in something like 100,000 years, which is actually comparable to the time scales for collision avoidance of another stellar system. If there was another planetary system coming towards us, and it looked like we were on a collision course. When I say collisions, I don't mean the stars are physically going to touch on the planets. They're too far apart, but I mean that gravitationally, they will get so close that they will perturb planetary orbits. And I found that the actual adjustments you need to make to the star's position to move it away from that risk is that similar sort of timescale. It takes of order of 100,000 years or so. So it doesn't mean to say that I think stars are conscious. I'm doing it as a thought experiment, and I wrote a paper on it, which just got out to those guys, and looking forward to getting their feedback.
It's when you said it to me, it really just reminded me of one of my favourite ever bits in any book ever, and it's Rudy Rucker's Ware Tetralogy. It starts off with I think it's hardware, wetware, and it just goes and it's all the different wares. I can't remember what order they're in, but I think it's the third book. Consciousness has been able to be transferred onto this mold. It's kind of weird mold type stuff that has a kind of
slime mold.
It's kind of like that, but it's a totally weird thing that's in the book that sort of comes into. He mentions it in a few other books as well, but this mold takes on a personality, gets loaded with a consciousness, and one of the main, there's 2 main characters that are molds, and they're traveling in a spacecraft when they're bombarded by a stellar wind, and that stellar wind has all the information of a stellar consciousness embedded in it, and the stellar consciousness is able to use the mold to come alive. So you lose two of the main characters that you've just come to know in one page, and it is taken over by a stellar consciousness. Yeah. And Rudy Rucker's very much about the consciousness being in absolutely any object that has enough complexity to be conscious. But it's a really, really interesting concept in that book, and it's dealt with all the way through, and it ties back to the very early books where the AIs and the robots have stellar wind as a way of randomizing their thoughts, and then it turns out that they've been directed by these stellar consciences all along. So it's a really it's a great sci-fi concept, but I mean, it would that really would be the most astounding explanation for dark matter ever, wouldn't it?
Yeah, I mean, I have to say that I'm not optimistic that this is what dark matter is.
No.
I have my own ideas that I won't go into at the moment, but I would say that I think it's an interesting. It's not even at the level of a hypothesis, right? So, in order for a hypothesis to, you have to come up with a testable prediction. Greg Matloff would argue with me that it is, because he's come up with a way of testing it, but and it's related to ideas of panpsychism. But I think in order to get to theory, then you need to develop the evidence. So I would say it's conjecture at the moment, and but I'm a physicist and I like doing fun things, so I just thought I'd run the calculations on the volitional motion idea, and I'm still sort of, as I say, in the steps of doing that. I'm also looking at the idea of a star as a brain, comparing it to, this itself is questionable, human consciousness. So we know that the neuron compaction density in the brain is pretty high compared to other mammals and other animals on Earth. So if you just take human consciousness, I mentioned the sort of processing operations speed earlier, sort of processing at 100 hertz, and then you can look at the similar sort of what's the processing speeds in a sun, in the star, in terms of how fast are sound waves moving, what's the the helioseismology, what's the frequencies of those, and just a very quick cursory look. This is not published work at all, and it's literally back of the envelope stuff. But I've concluded that if a star was conscious, then it's thinking a lot slower than a human brain, possibly of order 10 to the power 5 times slower, which is interesting. That 10 to the 5 number is also the 100,000 years I was talking about. And that makes sense in some ways. I mean, when you think about, there's ideas of trees or forests that have some ability to communicate with each other. If a forest, there's a certain tree which, if it gets infected by a particular aphid, and it starts generating a fluid, a pus, and the purpose of that is to alert all of the other trees in the forest, and all the other trees then develop this pus. And it's to basically ward off the aphids, right? So there's an argument that trees have a form of communication, but we don't recognize it because we think in very quick timescales. We think in terms of human timescales and the rest of the animals in our kingdom. But actually, if there is a consciousness in other systems, or consciousness-like behavior for big systems like mycelium or forests, or stars, I think it would be a lot slower in terms of the thought processes. And so that makes sense that a star would be thinking a lot slower. But then that brings a problem for me in terms of if it is the case that it's thinking of order 10 to the power 5 years, 10 to the power 5 times slower than the human brain, then how is it getting the information about volitional motion? How's it getting the information that there's a stellar system coming towards it? Because it takes a long time for that information to arrive, but it actually, relative to that speed, is quick because it's traveling at the speed of light, right? So it knows within years, but then it's got to process that information in its huge brain. So it's an interesting idea. I would say it's in the phase of science fiction. Another thought experiment I came up with, or an observation, I should say, which I pointed out to my colleagues, and I think they hadn't realized this themselves, is that if it was the case that a star was conscious, this actually then prohibits Dyson spheres. because it would not be moral or ethical to put a huge radiation cavity around an entity that we think may have some level of consciousness. And so if we can prove that stars are conscious, which I'm not optimistic about, this would, in my view, make it less likely that you could ever build a Dyson Stapleton sphere. And the opposite is likely also true, because although morality and ethics will differ with different civilizations in the universe if they exist, I tend to think philosophically that they would asymptote towards a certain understanding of the respect of life and its value, and they therefore wouldn't do that. So it brings in the whole question of carnage of civilizations, the idea that carnage of one, you utilize the energy of the entire planet, carnage of two, the entire star. Is that what you would actually do? Would you actually trap a radiation cavity around a star and capture all of its radiation? Because then, you then prevent it from any volition of its own. It's effectively a star prison.
Yeah.
And to me, this is a humanism versus naturalism argument.
Yeah, I mean, you could argue that there's a similar sort of thing already going on with, say, Mars exploration, where if say Mars 2020 rover detects microbes on the Martian planet that are native to Mars, then some people would argue that literally puts the kibosh on us going to Mars to inhabit it, because we would destroy that. Well, we would go into a pristine environment and destroy that native life, and that wouldn't be ethical. So it's a similar sort of argument, isn't it? That exploration always has some huge moral choices, and it's the same with getting energy, etc., etc. There's always some moral choices somewhere down the line to have to make.
Yeah, I think my own perspective is that although I have enormous respect for the natural world, and I believe we should live in cooperation with it, not in competition with it, I also think that it is our first priority, is think of it as triage, if you like, is human life as primacy. And is that our job is to first of all look after ourselves, and then to look after others if we can. So my argument would be that if we found microbes on Mars, and hopefully they were ubiquitous, and it wouldn't therefore matter if we farmed a few of them, or I personally would not allow that to stop our progress on Mars. I think we should build a Mars colony, and we should find a way to use those microbes for our benefit, to create an interesting ecology which we can exist in.
Yeah, I mean, I agree. I mean, I don't separate humans out of nature anyway. So I kind of think that everything we do is a natural process. I mean, I even call buildings natural because that's the way I see it. I think we're just, every other animal behaves in the same way. Birds build nests, and the bird doesn't look at itself and say, God, I was building that nest over some moss. How unethical of myself. So yeah, I don't know. It opens up some interesting things, but it's a really interesting thing, stellar consciousness, and the thought that I mean, that really would be such an incredible explanation for dark matter. I mean, we had one on the show a few weeks ago, which was dark matter is information. And someone from Southampton University was suggesting that in the same way that energy has mass, then maybe information itself has mass as well. And with a few calculations, she was showing that actually that would explain dark matter. If the information that's in a galaxy cluster or in a galaxy would be enough, this extra mass from the information contained within it would be dark matter, which I thought was really interesting.
Yeah, I have my own view on it. I'll maybe talk about it in a future podcast, but
yeah,
I'm doing some calculations at the moment. It's not something I've traditionally been interested in. I'm more interested in dark energy than dark matter, but I had an idea recently which I'm trying to pursue at the moment, and when and I like to sort of get something written up and scrutinise. What I tend to do when I write a paper is I pass it around a few friends to act as my filters before I show it to anyone else.
Yeah.
But yeah, it's an interesting question. I mean, this is the other thing. If we go back to the space travel, interstellar question, I mean, there's so much we don't understand. I mean, we've made so much progress in the scientific endeavour, particularly since the Enlightenment, but there's so much we don't understand. And, what is dark matter? What is dark energy? How can we test string theory? We still haven't discovered the graviton particle. We've only barely just detected the Higgs boson in the last couple of years. And so, are there extra dimensions? Is there any evidence of intelligent life outside of this biosphere, let alone life outside of this biosphere? What are we doing? I mean, we're just, these big questions are so obvious, and we should be really exploring them with bigger, and we're not. And the reason we're not is because we're caught up in our own problems and our own troubles. Too much nation-state rivalry, for example, not enough cooperation. And, we talked about the Chinese earlier. I actually learned when I was in Bremen that they're planning to launch a 100 AU mission. Like a Voyager probe mission. So good on them. I hope that they do that, and it'd be interesting to see the results. I'd like to see maybe we can help them and make sure that mission is a success if we can get access to the data, because it benefits all of us. We definitely need a better cosmic perspective, and this is my own view of my own journey, which really started in about 2007. In terms of these exotic subjects, and is I realised that, first of all, I realised I don't understand human beings at all, which is an interesting thing to realise. And my friends often tell me that I don't understand people. But secondly, we're so complicated. I mean, human beings, we're full of emotions, and we're just so complicated, and we're so disorganized. I mean, if we could just, something like Apollo, it forces us to focus on something, right? So, or something like trying to put together the Human Genome Project, or just these big projects really focus us. And I'm hopeful that one thing that will come out of this horrific pandemic, which has, sadly seen the loss of enormous amounts of life around the world, is that it refocuses our priorities a little bit. Makes us pay a bit more attention to the broader picture, and also helps us to focus on what some of the existential threats really are to humankind. I mean, other than pandemics, like a lot of people, didn't know a lot about pandemics, but when this started, I started doing research on it and reading it, and it's like, oh, I didn't know about all those ones. And you see how many people have been lost over the years, and it's like we have this forgetful memory. We forget. But it's all in the books and in history books. One of the periods in history I became interested in was the Younger Dryas, sort of 12,500 years ago. And there is pretty strong evidence of a cometary or asteroid impact on the North American ice sheet, which basically led to those massive melt flows of water and ended the last ice age effectively. We know that impact events occur. We saw one, was it 2001? We saw the Jupiter collision? 2000?
Yeah. Well, whenever it was, yeah.
That was
Shoemaker.
Shoemaker leaving 9. And then we had an impact in Russia, it was only a year or so ago. And we know that impacts occur all the time. I'm not convinced that we're doing enough, because, we can have a massive catastrophic failure of a society overnight. One of those impacts a city. If that one that hit Russia last year had a slightly different angle or different speed, come in at a slightly different entry point, it could have been we could have been talking about that. We could have been saying, how comes we've lost 500,000 people? We need to pay more attention to these bigger problems. Humankind is on this beautiful planet, the power blue dot, as Carl Sagan used to call it. And we're very fortunate. We've got these the beautiful jungles and the dry deserts, and the Antarctic and the Arctic, and just such very different terrains we can explore and learn about life, and millions of different species of life But we really need to pay attention to the threats that that humankind and all of the life on this planet faces in the bigger picture, whether it's pandemics or asteroidal impacts. And, I would like to see more focus on that.
Yeah, I mean, it's so hard. I mean, you're saying that you didn't understand humans. I don't think humans understand themselves or anyone really. It's very, very difficult to, particularly long-term thinking, long-scale disasters and catastrophes like pandemics. I mean, you'll have scientists that knew that this pandemic was definitely going to happen. It's like, this is definitely going to happen. But to be able to sort of motivate people into being able to see that it's going to happen, even if they see a documentary and they're watching it and go, God, yeah, that's amazing. Next day, they'll have forgotten it. They'll have forgotten just how ridiculous we should be doing something about it. And it's the same with asteroid strikes. I mean, asteroid strikes is the classic one, and super volcanoes and mega tsunamis and all these sort of things. I mean, everyone's forgotten the nuclear threat as well, which is still very, very real. And it's like, yeah, how do humans overcome that psychology? And I hope you're right about the pandemic issue, that once the pandemic has been controlled and we're at the other side, that internationally we'll have a whole new mindset of thinking about these things. I just hope that the right people win the narrative at that point, because there's been certain times in history where horrible things happen and the wrong people win the narrative. And it's just like, they're missed opportunities in that sense.
Yeah, I think my perspective is that we need to get away from politicizing science. Whatever the field, I won't go into any specific fields, but whatever the field, science needs to maintain its objectivity and its ability to be non-biased. Science has as much color and flavor as any discipline of human thought. I mean, there's humans. You only got to look at Albert Einstein's life to see how amazing his life was, let alone his physics. But we need to get away from the bias that influences science. Scientists should be in a position where they can, just like a professor who has tenure, in principle, can make a statement on a position of something, and there is little repercussions, because what's primary is the integrity of free speech. And when we lose free speech, we lose, I think, a lot. Because yes, a lot of free speech can be inflammatory or bigoted or whatever pseudonym you want to apply to it. But I think that that's a small minority. What's important is diversity of views. So as any field of thought, whether it's what we should do about asteroids, pandemics, or climate change, or whatever it is we're talking about, I feel that science should be opened up to the maximum possible broadest views, and the integrity of those scientists' objectivity should be preserved. And then the politicians need to be better educated in how to take that information and turn it into policy. Because I fear, in particular with the current pandemic, I'm not criticizing, I'm in the UK, but I'm not going to criticize the UK government, because it's in a very difficult circumstance having to deal with this tsunami which rushed at us, although you could argue it was predicted by someone who said we should have better preparedness. But I do worry about, they're listening to certain science advice to the exclusion of others. And Freeman Dyson took a view in his life that he was a contrarian. If he was in a room and there was consensus developing around a particular viewpoint, he would deliberately take an extreme view that's the opposite of all the others, not to be awkward, but because it forces a debate. It forces a discussion about the subject. And in order to have a proper debate about something, you need extremes of positions. And that's one of the things I like about multiple religions around the world, because no one really knows the answers to, the omniscience and omnipotence of the cosmos. But they all have different perspectives, and it enables you to kind of take your own bearing and help to guide your own life, because you can look at those different extreme points of view. So this is where science needs to get back to. It needs to get away from politicization of facts and truth.
Yeah, it's amazing, isn't it? The philosophy of science has become not such a well-taught subject anymore. I mean, if you think back to the sort of greats like Bertrand Russell and people like that, Bertrand Russell pretty much says exactly what you've just said then. He's very much about that whole, it's about the objectivity, but sometimes other people have different points of view, and you need to listen to them, and sometimes you might come to different conclusions, and that's that, and you just have to learn to live with each other and not want to have the truth because it's convenient, and it's just whatever the truth actually turns out to be, and you just have to accept it. And it's just like the philosophy of science is it's somehow not that trendy a subject anymore. It's not thought of as a kind of highbrow sort of thing. But I think you're right. I think it's actually extremely, extremely important, because the philosophy of science will tell politicians how they're supposed to respond to the scientists and everything else. So, I mean, the only good thing about this, the government response, I would say, to COVID-19 is at least they are listening to the scientists. At least there is science involved. Whether their particular response to it is perfect or not is definitely going to be something that's going to be picked at for years and years and years to come. But you can look at some of the other nations around the world and their failure to even engage with the scientists on the subject, and it's absolutely shocking.
Yeah, and also I think it's okay to disagree with people, right? So there's the other thing: if people have a different, the actual definition of an argument is, two different ideas that sort of are not consistent, and it's okay to have. Doesn't mean it has to be volatile or aggravational. You can disagree with someone, but what needs to be the arbiter, the test, is truth. And so, if someone makes a statement about something, you should be able to test that statement against facts, against truth, what we know. And that seems to be where we are at the moment, is in a war for what is truth, which is a bit sad. And I think that war is happening, particularly in social media, because we live in a poorly educated populace. We go back to the Roman and Greek times, they talk about things like the trivium and the quadrivium, and the importance of mathematics and reasoning and ability to form a logical argument, and having knowledge of geometry and architecture and astronomy and all the disciplines of thought. I think that the problem is people don't know how to construct an argument, and they don't know how, which means they don't necessarily know how to take apart an argument. So when you get people making statements of what they think is truth, or on science, which then has a bearing on policy, people don't necessarily know how to take that apart and understand whether the argument they've made is a valid one, or is it a logical fallacy, for example. And I frequently watch the news and just see politicians doing this all the time, that they contradict themselves in their statements. We saw that only a week ago, but I won't go into it. And so I go back to education. I think it's really important that we educate the people, the population. I mentioned that I came from humble beginnings, and my education really came about post-school, not during school. And I self-taught myself a lot of things. I read books on logic and reasoning and how to construct arguments and so forth. And this is really important because that's how you can see through the noise. Particularly when we live in this world where we're just inundated with information. It's just so much coming at us every day through our iPhones, through the news, through the radio and podcasts, and what do we believe is true? And I think that critical thinking is a really important skill, and it goes to all of our endeavours.
Oh yeah, I couldn't agree. That's one of the things that keeps me in my job as a lecturer. I think that higher education is so important, and for me it's the kind of what I do notice is that the way that the school system has gone is that it's so results focused that, of course, as a teacher you're sitting there going, well, I've got to get some good results, And there's a shortcut to getting good results, and that's to teach children the answers. And one of the things that you miss out on then is to teach children how to get to those answers themselves, teach them how to think, and teach them how to acquire knowledge, and teach them how to research. But if you've got this pressure of league tables and stuff like that, then of course it's going to go out the window. You've literally set up a system that skews the whole table towards the wrong type of learning, and it's really depressing.
So one of my heroes was Richard Feynman, as a physicist, and he had the view that it's about understanding. So in principle, if you understand the foundations of physics, you can derive everything else that is claimed to exist if you understand the foundations. And so that is, I think, where the emphasis needs to be, understanding. So what I fear is happening is that children are being taught to pass exam papers, and they're getting lots of really high grades, but it doesn't mean they have an understanding. So they might have done some papers on equations of motion or something like that, but did he actually understand what they're doing? I remember even on my master's degree, I did an exam. My general relativity exam was a Russian teacher. Typical Russians are very, very smart people, and he announced at the start of the exam, no calculator. Right? This is 2002, and we sort of took a big breath of air. What? No calculator? We were horrified. It's like, I'm going to do an exam on general relativity with no calculator. And I basically had to do this exam paper. And I remember, doing these calculations, back of envelope, powers of 10 notation, and working out the coefficients. There's a particular problem I had to calculate with two neutron stars colliding, and I had to work out the wavelength for the gravitational wave. And I just remembered from memory that it was of order 10 to the minus 11 meters. And it was one of the proudest moments of my life when I got to this long calculation without a calculator, and I got to 10 to the minus 11 meters. I knew it was correct. But it turned out he was wrong to have done that, by the way. The university told him off for it. But my point is that, the ability to do those sort of calculations and understand what you're actually calculating is an important part of science. And it's the same in any field, whether it's languages or history. I think academic rigor is really important, but I don't think the best way to drive that academic rigor is necessarily through tests. Right? So maybe at the higher level, the higher age level, you need those exams. But I'm not keen, for example, on children being tested at all before the age of 10. I think children should be children, and they should just have fun and learn through fun. And I think that's what it should be about. I'm a fan of. I can't remember his name now. It's one of the biggest TED lectures on TED. I can't remember his name. He's a former member of the Shakespeare Company in Stratford-upon-Avon. But he gave a very good talk on creativity. And, I think creativity is also very important. He was criticising that, the science, engineering, and maths tends to be given more priority. I'm not sure that's true, but he was trying to make the point that we mustn't forget about creativity, because creativity is what solves problems. And I also agree. I think creativity and imagination is very important. I mean, my daughter's very creative. My oldest daughter, she's just making things all the time. And I was like, how did you come up with that? And I try to encourage it, but she doesn't really need the encouragement. She's just making things, just astounding things. And we lose that as we get older.
I mean, I don't even get the argument about maths, for example, not being creative. I distinctly remember, and I still have this, where writing a song or finishing a maths equation have exactly the same feeling of a creative leap for me. It's like literally, it's so creative to solve a mathematical problem in the same way as writing a song. It's exactly the same thing. So to be encouraged to be creative. I mean, creativity is all that we have. Particularly moving into the era of AI and machine learning and everything else, human creativity is going to become more and more and more and more important. Who cares that you can operate a calculator, because my computer can do it 5 times faster than you.
Well, it's the same with the conscious stars debate. I mean, It's probably not the case that stars are conscious. That's my position at the moment. But it's a heck of a lot of fun to think about it.
I know, no, exactly, and that's why I love having that stuff on my podcast, because I think there is why not deal with something that would be considered outside of mainstream science? Well, just because it's outside of mainstream science doesn't mean that it's necessarily wrong. It just means that it's fun, it's creative, it's got some kind of it's not, it's not just something made up that's completely ridiculous. It has some kind of fun element to it, and maybe it will lead to something. I mean, it would be the most astounding discovery ever. The dark matter was that, but yeah, I think that there's one point that you did make, and that's the this ability to sort of argue with someone and realize that you're arguing against the things that they believe and not the things that they think they are. And a lot of the time now, I think a lot of people are their entire narrative about who they are is wrapped up in their beliefs and the things that they believe in. And therefore it's very, very hard to have arguments, because the moment you start unpicking some of the things that they're saying, they feel as though you're having a go at them.
Yeah,
and that is so common. And I must admit, I've never really had that. Occasionally someone will say something where it'll make me angry, but I realize how wrong that is. But I realize that when you talk to people, it's very, very hard to bring people out of certain positions that you feel are wrong, or that they're talking nonsense. And you only have to see how that how that kind of unwraps on social media. You say something, and if someone disagrees with you, they don't have a go at the point that you're making. They have a go at you. They say, "Oh, you're an absolute 4-letter word for believing that." It's like, please just don't do the ad hominem thing. Just do
it's an ad hominem argument in logic. But yeah, it's
that whole the logical. I mean, logical fallacies are a great place to start. I think when it's sort of looking at reason and critical thinking. I think that's.
Yeah, I mean, you kind of, you don't want to go either extreme, because the thing is, if you just become a Vulcan and just did logic,
yeah,
then you kind of potentially kill the creativity, because you're only prepared to speculate based on tiny perturbations of the known, right? And so, but if you're prepared to be creative, I mean, the idea of thinking about a conscious star is not logical, because there's nothing in our knowledge of science in the world, the natural world, that you could extrapolate and say, therefore, it's possible a star may be conscious. It's very difficult. There's nothing you can extrapolate from. So therefore, it's a complete creative jump that's not based on any inference of anything that's known. But what you can do is you can apply our knowledge of physics, for example, and to that system, and say, well, if it was conscious, what would it look like? And then once you run the numbers, you can see what's possible and what isn't, right? So maybe there's a reality, another universe where such a thing would have been possible. This is the same for things like wormholes and warp drive. There's no evidence at the moment in physics that wormholes or warp drive exist, artificially or naturally. I would argue that wormholes are slightly more plausible than warp drive for different reasons. But however, people publish papers on them all the time. The idea of taking the Einstein field equation and taking the space-time metric and reshaping it to give a different geometry, a different coordinate frame, which then changes your equations of motion, and then you run the Einstein field equation to work out the properties of that system. And what you find is you need enormous amounts of negative energy in particular, which doesn't exist naturally in the universe. But we have ideas to create negative energy, something called the Casimir effect. So that's interesting. It's like, okay, so is it possible that we could create microscopic wormholes? Well, it may be. There are various reasons in physics for thinking it might be possible at the microscopic level. If you could do, because, they go down to the microscopic level, what is fundamentally space? You've got two competing theories of string theory, which sees tiny particles as like oscillations on strings. And that's really a kind of ground unified theory successor to Einstein's pursuit of that. So it's a success to Einstein. And you've got others like loop quantum gravity, which is, they're actually looking at the discretization of space itself in a way that you'd have, say, atomic energy levels in an atom. Well, John Wheeler published a paper years ago where he showed that you go down to the quantum level, right down to the Planck scale, because of the quantum uncertainty, you have what's called space-time foam. And so space and time are intermixing, and you get all these little tiny chaos of it's not necessarily a continuum. It's there's just this chaos and of these dimensions coming in and out of existence. And it's possible that you can, in principle, take one of those dimensions and inflate it for a second, so it goes bigger. And then maybe you could pass a particle through it, or even a photon of information. It was just one bit of information. That's then, a form of telecommunication, which would exceed the light barrier. So that's one way we think we could do it. But this is, this goes to spooky action at a distance and quantum entanglement as well, which is another subject. So we know there's some interesting physics we need to look at, which is pointing that the world is a lot more complicated than we think it is. The world's a stage, as Shakespeare said, but there's a lot of complicated stuff going on underneath it and behind it. And I'd like to pull back that curtain and see what it is.
Yeah, we all would. Well, if only I was brainy enough to even start. It's really fascinating. All that stuff of where can we go? It's amazing, isn't it, that like 30 years ago they thought they'd almost solved science, that we were almost there, that we were at the
even Hawking said it.
Yeah, and it's just like we seem further away now than we've ever done, because we've opened up so many different areas of things to look at. Now, the point I was going to make about your stellar consciousness, I think what's great about that is the having that creative urge to have a look at something like that. And you never actually know that the stellar consciousness might be a complete dead end and complete, but it'll never be a waste of time, because you'll be able to see it may have given you insights into something else. The fact that you've done these equations to look at what other things might be conscious, you might someday be walking down the road and have another insight that you wouldn't have had you not have sort of put your brain to this other puzzle. And that's what I love about creativity. It's this never-ending onion that keeps going down and down and down and down and down, and the more creative you are, suddenly the more ideas keep coming in. This is what songwriting, for example, is classic. The more songs you write, the more likelihood it is that you're going to hit across this great song. And just because you wasted your time on a song that was fairly mediocre or even rubbish, that song, you may not have been able to get to your great song without writing this mediocre song. So don't worry about it. Just enjoy the process.
I agree. Yeah. But it reminds me of, you go off into the Amazon rainforest because you've been given a grant to try and find a particular beetle or something. And you stumble across an ancient Aztec culture or something, or civilization that we didn't know existed. Or these are sort of sometimes science needs to be done just for science's sake, just for the exploration's sake, and we need more of that.
Oh, absolutely. I think it has to be done. I think speculative science and just research, you never know where it's going to go. You never know where it's going to go. And it seems like all the biggest breakthroughs in science have always been like that. You never know. There's no way that Einstein could have known that looking at the speed of light and doing all those things was going to lead to the invention of the atomic bomb, for example. Yeah. And, if he had known, God, would he have got a big grant to have done it? How much would the American government have given him to go, here's a big grant for you to come up with a nuclear bomb? So, you just never know where it's going to go. And I think that's why it's really important that it's protected.
So that's an interesting point, because one of the views I've actually come to is that obviously I'm a scientist and I have many friends who are scientists, and I think scientists are really cool, creative people, produce a lot of cool stuff. But I also come to the view that I don't think that important decisions about whether you should make something should just be left to scientists. Because I think if you just take the Manhattan Project as an example, you sort of alluded to that. We're talking about Einstein a little bit. Richard Feynman talks about how after the project ended, he realized that he enjoyed it too much. And he started thinking about the world differently. And I've been in that exact position where I was in a job, and you're head down doing the calculations, and you're enjoying it, but you stop to think whether you should do it. Whether that's the right direction. So when we open up these new avenues of science investigation, there's a possibility of uncovering things which have the potential to do enormous good to society or enormous ill to society.
This is dealt with really, really well by, funnily enough, a scientific philosopher called Nick Bostrom. Do you know Nick Bostrom? Yeah, he's recently been talking about a thing called the urn of invention, which is basically a bag full of white, grey, and black balls, and you stick your hand in and you pull out a white ball, and hey, it's an invention that's really good for everyone, like penicillin. You pull out a grey ball, and it's like, oh, it's a really good invention, like general relativity. It gives us lots of energy, but it also gives us a nuclear bomb. Oh, that's a bit, it's a little bit. There's a bad side and there's an upside. There could be one that you pull out and it's a black ball, and it's an invention that, say, his analogy is that you pick up some sand and you can stick it in a microwave, and you can blow up a city with it. And this invention now is so bad and so terrible that you've ruined the future. The moment that you have a city destroying technology that's really cheap that anyone can make, it's like, now you're in really serious trouble. And he looks at how you kind of prevent these things from happening, and looks at what you do if someone does pull out the black ball of invention. And it's a really, really fascinating paper. I mean, it basically, I think, ends up with the conclusion that you're never going to stop scientists looking into stuff, and you can never tell who's going to put their hand in and pull out a black ball of invention. But if it does happen, then we'll almost certainly have to have what he calls a turnkey dictatorship, whereas like everything's on lockdown from that point on.
Yeah, so this is what I was alluded to earlier about. I'm not sure we're mature enough yet to get out there, because I think all those issues like our ethics and morality, our governance structures, we haven't quite figured out yet. Because you certainly don't want to get to a system where everyone's basically living under a dictatorship. But also, I mean, I'm a huge believer in personal liberty, but there needs to be some restraints, I feel, on what people can do if they have there's the information, the knowledge to do something, and then there's the technology or the tools to do it, right? So, I mean, talk about Manhattan Project again. One of the concerns they had when they were developing the bomb, in particular the hydrogen bomb, is that they were worried that they could set fire to the atmosphere, right? So that was considered a very low concern, but they ran the calculations theoretically, and they concluded they didn't think that was going to happen, and so they went ahead and built it anyway, right? Because I think the risk is very low. So how much of the world was involved in that decision to, what was that calculation? What was the probability? Was it 1 in a million? Was it 1 in a billion? I can't remember the calculation, but who was involved in that decision? Same with CERN. When they were building CERN, there was, because at the time, and there's still some belief that there are more than 3 spatial dimensions, and it was believed that if you look at the calculations, if there's more than 3 spatial dimensions, the Schwarzschild radius for gravitational collapse of two protons colliding at 7 tera-electron volt energy, it changes because the Planck length changes. And so actually, it was possible, in principle, if there were more than 3 spatial dimensions, for those 2 protons colliding in the particle accelerator at CERN to collide into their own Schwarzschild radius. Now, the problem is that people misunderstand black hole physics, of course, but because due to Hawking radiation, the radiation is inversely proportional to the mass, so they irradiate instantaneously, like a fraction of a second, and you just get a shower of particles coming out. But, there was some guys writing papers on this, and I think there was even a law case trying to stop CERN from switching on, but it's like, until we've done more work on it. It's like, well, what is the risk that you're going to create a black hole and destroy the Earth's going to disappear inside of it? There's two arguments to that. One is that, they just don't understand black hole physics, because these are microscopic black holes which decay in a fraction of a second according to Hawking radiation. However, that hasn't been experimentally verified. No one's actually experimentally verified that a black hole that's microscopic will radiate inversely proportional to its mass. And the verification for that, even with macroscopic black holes, is very, tenuous. So there's that element. And then there's the other element, which is, who makes these decisions to take these risks in society? I'm not trying to suggest for a moment that I think scientific experiments should be stopped. But what I am saying is that when you are dealing with the frontiers of science and knowledge, whatever it is, you have to take care, right? And that includes even going out into the universe. We don't know what's out there. We don't know what's waiting for us out there. All these discussions about METI, transmitting signals out into the universe, our radio signals have been transmitted for the last century. So, for principle, they're at 100 light years already. But we don't know. There might be some bad civilizations out there who, we've got lots of horror films. Aliens is a classic one, which is a brilliant film, describing those sort of scenarios. Prometheus, where they decide to bring the pods to Earth to destroy humankind. We don't know what's out there. And therefore, even in space, I think we should tread carefully. And I feel that discussion needs to be broader than just the scientists. And I don't know if you ever saw the original Contact film based on a novel by Carl Sagan.
Yeah.
Starring, I forget her name.
Jodie Foster. Yeah.
Jodie Foster, a brilliant actress. And they had this big debate in the science committee, and I think it was in Congress, where there's religious people asking her, well, do you believe in God? And so they have this big debate, and should we switch this machine on? And in the end, they switched the machine on. Of course, I don't believe her. She made the journey. But, my only point is that my own feeling is that there needs to be a broader discussion than just the physicists, because physicists are very smart people, and they're very creative. But once you get let's say it was true that a bunch of physicists could prove a star was conscious. What's the implications of that? I'm not sure I've even thought that through.
Yeah,
I'm just fun to do the calculations, and I believe it's a very low probability that they are conscious, but it's fun to do. But what's the implications of that being true? Same as when we talk about, I've been watching a beautiful documentary on trying to find an abominable, not abominable snowman, a yeti in northwestern forests of North America. Really interesting. A bunch of scientists trying to find the evidence for this thing, and evidence doesn't look strong. But what if you did find this thing? What if you did find that it's actually some offshoot hominid, goes back thousands of years, and back at the time of the Neanderthals, maybe it's Australopithecus or something. What's the implications of that? Well, we're going to put it in a zoo. That's what we're going to do if we found one. So maybe we shouldn't, find it. I don't know.
Yeah.
So scientists are curious, and they want to know. They just want to know things. And I think sometimes it's not always wise to know.
Yeah. Oh, we're going to have to wrap it up there, Kelvin. Thanks very much, and stay safe.
Okay.
The Interplanetary Podcast is alive!
Lovely.
Apologies for the sound quality. Like I said, I was going to go around his house, but we ended up having to be a phone one because of COVID. Thanks, COVID.
Thanks, COVID. Thanks again.
We could mention the other story I wrote up, which was a paper called Discovering New Strong Gravitational Lenses in the DESI Legacy Imaging Survey.
That sounds like a quick one.
It's a very quick one. Now, I will stick this in the notes, but essentially what this is this team they've used machine learning, known as deep residual neural net, to train a computer to look for gravitational lensing events in this enormous data set that comes from the Cerro Tolo Inter-American Observatory and Kitt Peak National Observatory. This huge data set, and they've found 1,100 odd new gravitational lensing events, which is more than all astronomy has ever found ever before.
Wow, that's pretty amazing.
So yeah, so they've managed to find all these gravitational lensing events, and what makes them special again is these types of knowing that you've got these gravitational lenses out in the universe. It's really useful because now we've mapped where all these gravitationally lensing galaxies are. We can keep an eye on them because certain events that would get lensed by these enormous galaxies that are bending light from behind them, now we know that they're there, we can look for things that might be really useful for us to be able to understand how the universe is put together. For example, if a supernova happens behind the galaxy and is lensed by the foreground, there's loads you can learn from that about general relativity. You can test general relativity even further. And so, yes, it's a very, very powerful tool for astrophysics.
Fantastic.
And, and you can study dark matter and how it's distributed in the galaxies and all these galaxy clusters and things. So it's now, basically, it's just massively increased this map to look at the universe in a new and interesting way.
Well done, Huang.
So it's Zhang Shuanghang at the University of San Francisco. And they use the National Energy Research Scientific Computer Center, or NERSC, supercomputer.
I love a good acronym.
Berkeley Lab. There we go. So well done. That is a great little story, that one.
Superb.
Chris, what are you doing this week?
Staying at home, Matthew. Staying at home, saving lives.
Excellent.
You know, they've gone into a tighter lockdown here, which is very understandable. The variant has arrived, and it's obviously that the numbers here are not even comparable, but they are very, very strict on things. And as I said to you before we started recording, you can only buy wine and spirits in one place in Norway. There's called the Vinmonopoly, which is the wine monopoly. It's just controlled by the government, and they closed them without any notice. So, but that's a good thing, because I'll stay at home and be sober, which is a goal.
So you basically landed on the income tax square just as you passed go and didn't get your 200 quid.
Pretty much, yeah. So
that was
I'm going to be
wine monopoly move.
Yeah, wine monopoly move. Yeah. So yeah, I'm going to be staying at home, do a bit of work, spend some time with my dear wife, who's also going to be working from home, and just look forward to hearing this on when it comes out. Of course, I always enjoy hearing. I like hearing your voice, maybe not mine as much.
Ah, it's beautiful. Do you know what? I do like listening to podcasts. I think podcasts are really, really good in lockdowns. It's quite nice to hear other people's voices and just sort of be sat there in a conversation. I genuinely think podcasts have been really, really good in lockdown.
So many that I've just absolutely loving. But I will recommend Daniel and Jorge Explain the Universe. It's great. So I listen to that a fair amount. One of them's a comic book writer and a cartoonist, but also a sort of excited about physics, and the other one is a particle physicist. So they basically just pick a subject every week and go at it. It's really enjoyable.
Oh wow, cool. Yeah, do I have a recommendation of a podcast? Nah, you can find it. A Recovering Queen. That's the best one.
Yeah, I've heard that's pretty good.
Oh, yeah. Amazing.
What are you up to, Matthew? What are you going to be doing?
It's the first week back of lecturing at my place, so I really have got an absolute nightmare week of work. I've got 6 modules I'm teaching for some reason, so it's full on. Yeah, it's full on for the next 5 weeks.
Good luck, mate.
Yeah. ouch is the word. But yeah, hopefully, it won't affect my podcatting.
Get out, breathe in the air, enjoy the sky, ride your bike, go for a walk.
Oh, there was snow on the hills today. That
Lovely. Yeah, that's what we need to do. Just get out there and just breathe in. And as Bob said on the Discord, 1 hour of exercise that sort of at least gets your breath going and maybe gets a sweat on, and you try and do that as much as you can.
Oh, shout out to Bob. He's at the top. His jurisdiction where he's handing out vaccines is the top performing area. And that is a lot of it's down to Bob, apparently. So, in terms of he's gone out there and done lots and lots and lots and lots of vaccinations. So well done, Bob. You are an absolute legend,
Super Bob,
truly a legend. I mean that like being top of the league table in Britain currently for the vaccinations means you're probably top in the world, right?
Pretty much, yeah, absolutely amazing.
That is well done. What an absolute legend.
Absolute.
That's it. Bye,
okay.
Bye, Spark!
Bye, Sparkats. Bye, Sparkats. Bye, Sparkats. Bye, Sparkats.
More fun in space.